In this module, we're going to look at reaction rates, specifically the factors that influence reaction rates. So in chemistry, we like to examine the qualities that influence how a reaction will occur. So let's look at a reaction. We take two colorless solutions, and when we mix them together, it changes to give us a different color. That is one of our signs of a reaction, changing color. Temperature is one component that can influence the rate of a reaction. So let's look at the same reaction under three different conditions. In one, we're going to heat this solution to see what it does to the reaction, and in another, we're going to cool it down. And when we mix them, we will find that the one that is heated goes faster, and the one that is cold goes slower. And we want to know, why does this happen? So if we are going to think about why this happens, we want to know about chemical reactions. They occur when chemicals combine with enough energy and the proper orientation. That is what makes a reaction. If they don't have enough energy, when they combine, nothing will happen. They'll just sort of bump and move each other, but there will be no reaction because they don't have enough energy to cause the reaction to occur. If they don't orient properly, meaning they don't hit in the right way, then also no chemical reaction will occur because chemicals have to hit in just the right way for a reaction to happen. Anything that will increase the likelihood that chemicals will hit in the right way and with enough energy will make the reaction happen faster. So how does temperature do this? If we think about the reactions, temperature is the average kinetic energy of the particle. So it's really how fast the particles are moving. So every particle is moving at a certain speed. The average speed that they have is going to be their temperature, or it's going to be what we use to determine their temperature. If we increase the temperature, that means we increase the movement. So if we heat them, they move faster. Now, when they move faster, that means that they're going to hit each other more often. If they hit each other more often, there's going to be a more likelihood they hit in the right way. Also, if they're moving faster, they're going to hit with more force. So it's more likely that they will have enough energy. So particles collide with more energy, and they collide more often, so they are more likely to collide with the correct orientation. So reaction rate increases when temperature increases, and decreases when temperature decreases. So temperature is one factor influencing reaction rate. Another factor is agitation, or stirring. When we stir something, we are artificially speeding up how much they're moving. So stirring has the same impact as a temperature change, only we're doing it by moving the particles themselves instead of having everything move faster. So when you stir a mixture, they move faster, they collide more and hit harder, so they're more likely to hit with enough energy and correct orientation. So for agitation also, the reaction rate increases when stirring increases and decreases when stirring decreases. Another factor is surface area. If I look at a particle, if I have a solid like one big clump, the surface area is limited by how many particles there are. And only particles on the surface can react with the correct orientation. Because if we look at them, other particles are prevented from reacting by their solid structure. Because in this particular organization, only two of the particles can be hit in the side where they need to be hit, so only those two particles can react. The amount of reaction is limited by the surface area. If I break those particles up, so if I break into smaller pieces, there is more surface area. So there's more area for them to react. So for surface area, reaction rate increases with more surface area and decreases with less surface area. Concentration. Concentration is a measure of how many particles there are per volume unit. So if we only have so many particles, only so many of them can react based on what we have. If the concentration is greater, there are more particles. If there are more particles, then there are more things to react with the right orientation so that we will go at a faster rate. So reaction rate increases when concentration increases and decreases when concentration decreases. Our last factor is something called a catalyst. Now a catalyst is anything which speeds up a reaction without being changed by the reaction itself. So if I look at my normal reactions, there's a bunch of particles that could strike with the right orientation. If I add a catalyst, the catalyst attracts and draws those particles in so that now those particles can only be hit with the right orientation. Because they can only be hit with the right orientation, that means the reaction is going to be speeded up. And when those chemicals react, they will go away, and the catalyst will be available to react with more chemicals. So the catalyst is still there when we're done. It's just the reaction goes faster because they have a better orientation. So reaction rate increases with the addition of a catalyst. So as we look at the factors influencing reaction rate, they are as follows. Temperature. Reaction rate increases with increasing temperature. Stirring. Reaction increases with stirring. Surface area. Reaction increases with more surface area. Concentration. Reaction rate increases when concentration increases. And a catalyst. And catalyst always speeds up a reaction. So of the 5 things that we have, when we're looking at them, an increase in any of our factors will increase our reaction rate. A decrease in any of our factors will decrease the reaction rate. Here's the end of the module on reaction rate.